gonna light a candle. Welcome back. So I've been trying to catch up on the last 10,000 hours of missed lectures. I've been simultaneously taking a lovely trip down memory lane back to my earlier years of undergrad. And the reason I've had to do this is because I've actually had to go back into some past course material to relearn some certain things in order to better understand what I'm learning now. I can't help but think, Lana, why? Like, what could you possibly have been doing instead of paying attention and learning it the first time? So that has actually inspired me to reflect and think about some advice that I would give to my stupid, wasteful younger self. So I'm gonna split this video up into two parts: the academic advice, and then part two is gonna be the identity advice. And I'm gonna put timestamps for both of those, that way you can flip back and forth between the two of them. And so without further ado, so starting with advice 0, actually, because this doesn't fit into either one of those categories, go to community college first. But like that's like the one thing that I will never ever forgive myself for not taking seriously when I have the time to do so. Like, it literally goes without saying how much cheaper that route is. Like, literally, like, forget the stigma, bro. Like, watch your wallet. So starting with part 1, academic advice. So I'm gonna do all the technical stuff first, that way I can get that out of the way. So my very first piece of advice to myself is definitely pay attention and drill the hell out of your foundational courses. And I specifically mean the courses Calc 1, 2, 3, and 4, linear algebra, signals and systems, circuit analysis, circuit systems, electronic devices, and by that I'm referring to the course where you're first introduced to semiconductors, and last but definitely not least, principles of programming. These classes, they may not seem like much when you're taking them, and you might not be able to immediately see the connection between what you're learning and some higher level applications, but I promise you these are literally the backbone of every single electrical engineering principle. Not having a hyper comfortable understanding of these skills will make upper year level coursework so much harder to grasp. So drill them, pay attention. If your professor assigns practice problem sets, do them all. If you get access to past exams, past tests, any past practice problem sets too, do them all. Like, don't skip anything, exploit every single theorem that you get, and literally make sure you understand everything forwards and backwards. Number 2, MATLAB. So I know some universities actually have this as a standalone course, and I think that actually would have been helpful, but my school didn't. Not only is MATLAB such an insanely powerful tool, but it's actually really heavily used in industry too. And if used properly and if understood properly, you could actually also save yourself a lot of time on assignments. So MATLAB, like, it never goes away. My thing was that when I was in my first couple years, I just thought that, you know, MATLAB, whatever, I'll just BS it, I won't have to see it again. It shows up in every single course, and even when it doesn't show up, it would make your life so much easier. So MATLAB, know it, love it, use it. So advice number 3, don't expect shit to get handed to you, even though you're paying for the education. So one thing I wish I started doing earlier was using the textbook for every single one of my classes. If you're a non-STEM major like watching this and you're like, how do you get away with not using textbooks? Like, literally for a lot of our courses, like, the course notes are usually sufficient enough to pass the class. So textbook usually hold little minute details that your professor and even sometimes YouTube videos don't really necessarily cover. And if you want to be able to, you know, string together concepts between classes or between projects or between challenges, those little details make all the difference. Actually, in addition to using textbooks, so this is going to be like advice 3.5, I want to stress how important using documentation is. Like, whether you're using a piece of hardware or some kind of computer software, referencing the actual original documentation provided by the creator of the thing is usually faster at finding whatever you're looking for. Even more than that, it usually provides you with a more in-depth answer than just trying to find some kind of shortcut answer through Google. And I know it might not seem as practical, but you do get a lot more out of using documentation. That way later you don't have to keep going back and trying to understand new things or whatever. Like, documentation, use it, all the answers are right in there. So my last piece of advice, number 4 for the academic section, is don't try to understand all of the theory to perfection before you try practicing problems or trying to build or simulate something, because you will effectively learn nothing. And the reason I say that is because sometimes you might come across like a fact or a key concept that doesn't immediately make sense to you just by reading the words. And so how I usually go about it now is that I'll read the fact, I'll read the concept. If it doesn't really make too much sense in words, I'll just write it down, and then I'll try practicing. And so by practicing and consistently getting the wrong answer before I finally get the correct answer, that's when I'm just like, oh, that's what that meant. Then the fact or the key concept finally clicks. There's significantly more to learn by consistently getting the wrong answer rather than getting the correct answer the first time. So when you get something wrong, like when your first approach is wrong, it forces you to find out why that approach didn't work. That way in the future when you come across a similar problem, you'll immediately recognize it and you'll be like, okay, that's why this doesn't work, so this thing works instead. And I strongly abide by the philosophy that it's not just enough to know why something is correct, but you also need to convince yourself of why everything else does not work. Otherwise, like, how can you actually convince yourself that what you did is correct if you only tried the one attempt and it just happened to have worked, right? And another add-on to this, I guess another 0.5, so 4.5, advice 4.5, ask an endless series of what-if questions. Going off the philosophy that I just mentioned, this is exactly how I learned to make sure that I thoroughly understand a concept. So, you know, asking questions like, what if I stretch these constraints? What if I increase or decrease a certain parameter? What if I change this configuration? What if I tried a different topology instead? Like, getting those questions kind of rolling in your head, thinking of like, what if this wasn't there? Like, what if this changed? Would the answer still hold, or would my approach still make sense? And that kind of exploitation of theories and exploitation of practice really gets you a deep understanding of what you're actually doing. So do that. So now on to part 2, the identity advice. This is actually my favorite section because I actually spent most of my undergrad focusing on building my character, building my identity, finding out, you know, who I am, what I want. So I love this section. Advice number 1. So from my own experience with my classmates around me, there's usually 3 major subdivisions of engineering student, and it's pretty much based on what they prioritize. So first you have the academics, so people that prioritize grades. And then number 2, you have the builders, who pretty much prioritize any application, design, building, creation, or building anything outside the classroom. And then you have number 3, the job hunters. Those are the people that really focus on getting internships throughout their undergrad, and they really prioritize full-time job security right at graduation. Most students that I know actually are a really good hybrid of multiple of those, be it just 2 of them or all 3 of them. So my advice to my younger self would actually be to pick what you want to be and prioritize accordingly. Whatever it may be as consistent as possible, and also make sure that you have enough room to evolve and just possibly change direction if and when you see that something is no longer fitting for what you want. Like I'm thinking about like younger me, like when I first started in engineering, I think I probably, like, if I had been explicitly given these 3 categories in front of me, I think I probably would have chosen academics. Blame the cultural impositions. I think eventually I would have ended up morphing into more of a builder with job hunter in a very distant second place, and that's pretty much where I am right now. So on that same token, advice number 2, be extremely mindful of the company that you keep. I think the truest saying that you'll probably hear throughout your entire undergrad is, you are a sum of the 5 people you spend the most time with. So it's really important to know exactly what you want, make sure that you place yourself in the environments that will help you produce those results, and more so, make sure you spend the majority of your time in those environments. And the reason I say majority instead of all of your time is that I know that I have a lot of interests that span way beyond engineering, so it's definitely important for me to make space and time for those other things too. And then advice number 3. Advice number 3 right here is the biggest adulting 101 lesson that will propagate throughout your entire life. Are you ready? Know when the party ends, and more importantly, make sure you leave before then. And I mean that both figuratively and literally. Having fun is important, you know, like, college life, woo-woo. But it's even more important to know when it's time to just return home and regather your focus. Last but definitely not least, this is a little bit of a harsher message, and that is, there is absolutely 0 such thing as perfect or optimal balance or comfort while you're a student. And to be even harsher, you don't really deserve to be comfortable. And the reason I actually say that is because the university experience is meant to be transformative. We're all here under the pretense that once we're done, our lifestyles are supposed to be significantly more elevated than when we started. Whether or not that's true, leveling up nonetheless is a chaotic experience. Like, nothing about it is comfortable, nothing about it is meant to be comfortable, otherwise it would be easy to do it and everybody would do it. So that being said, learn to live and thrive in chaos. Sometimes you'll wake up early, some days you'll stay up extremely late. You might ruin some relationships, you'll get some shit grades, you'll even have some bad self-esteem days, weeks, months, maybe even entire school years. You'll experience some crippling self-doubt. You will, not just might, but you will make some bad decisions, sometimes some irreversible decisions too, and you will cry a lot. And that is just part of this lovely life mosaic of L's. But you know what? We got it.